Other one, November the 14th. Alright, let's get to it. Shortest subarray to be removed. To make array sorted. Given an array, remove a subarray can be empty from array such that the remaining are sorted non-decreasing within the length of the shortest subarray to remove. Binary search, because we can go sliding window and we can how are you going to do so? Sliding window, we can get rid of a subarray, right? And after I get rid of the subarray, how do I tell if it's been increasing? Well, I can say if I remove this, but is it increasing for the remainder? Is there an easier way to check if it's increasing or decreasing? Maybe we can do, I don't know, throw out some stuff. Maybe it is 1, 2, 3, 10, 4, 2, 3, 5. How about pair adjacent? I get the difference from right to left. So this is going to be 1, 1, 7, minus 6, minus 2, 1, and 2. All right. So we know that if we do sliding window, let's say we do a 3, right? A 3, so this will be a 1. So let's just say we have a 0 at the front. Okay, we just say a 0 at the front. So we just, this is mock, right? So now we have the same length as this. And if I do these 3, it will be just these 3, right? So if I do these 3, then I can check the remainder to see if there's a negative. But I have to go this like sliding it through. I need to use O1 to tell if this is good or not. How do I use O1 to tell? I just by thinking right now, I don't see a way to quickly tell. Unless you already know their position. If you know their position, it's not very clear. How about monotonic increasing? 1, 2, 3, 10, 4. So I'll say I'll remove 10. And then 2 and 3, so I have to remove 4. I remove 3. Basically, if you do that, it's if I including this, right? What is the but you can also not include it. Is it increasing? Can we do a auxiliary array to tell if it's increasing? So from this we get if it's increasing. So we go right. So by itself, I can say yes. This two is yes. This is yes. This is no, no. Because they have no, so these are all no. To the end, it's all no, right? So basically, the end only these three is yes, right? And then maybe we can go right, left to right. Then we have yes, 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 no. Once we have a no, because it's starting from here, so everything is no. So once you're looking at these two, you will see that actually, wait, don't do it this way. Right, we basically say, if we still go binary search, right, we go 1. No, we don't go to 1, we go to any length, right? So we have a length, let's say we have a length 4. So we check this and it's wrong, so we cannot do length 4, right? And then we say the length 2, okay? Well, if we do length 2, what we want to remove is the shortest, right? So we remove length 2, and this is no. Moving here, yeah, basically, yeah, if we do length 2, this is a no. So we move down here, this is a no. Move down here, so these also have to check, is good. This is a no, move down here. Okay, so this is a yes, but then we need to compare these two, so that's a no. Then move down here, compare these two, that's a no. Move down here. Now we got a no, because this is no good, right? Because it's go down, so that's a no. So we have those 3. Okay, I think an auxiliary array shall work in this case. I think the and then aux if I smaller or equal to array I plus 1 and array I plus 1 and array I plus 1, not array I plus 1, auxiliary I plus 1, then auxiliary I true, else auxiliary else break. The first time that you can break. Basically, we just fill the truth, right? We just fill the truth. The first one. Yeah, exactly. So we basically just say I larger than and array I is smaller or equal to array I plus 1. We'll say auxiliary is true. Otherwise, we'll do false, right? Okay. Now we're gonna go from, can say, low equal to 0, because we can do 0. Yeah, you don't have to remove the entire thing. Array.length. I just do array.length. While low, small, high. int mid, low plus high. Okay, here's the idea. High minus low divided by 2. Okay. Now we should need I and j, right? So we can say for int j, we can say int I is equal to 0, j is equal to I plus mid. We want to remove these three, so I plus mid. Yep, I plus mid will give you the next one. Okay. Let's see, which one do we need? So we're gonna remove. I think we'll do this. Radar length, j plus plus. Okay. So we check the end first. Check the front. Check the end. Then we'll get Boolean possible. Works. So we set it to be false. No, we set it to be true, right? Okay, so which situation will be false? If, right, j is smaller than the radar length minus 1, minus 2, and if j is smaller than that and array j plus 1, not array j plus 1, auxiliary j plus 1, not, it's false, right? Then works equal to false. Okay, so that's one. And the other one is if I is larger than 0 and as I is the one that, so from I then j is removed, right? So we move forward, right? And then move. So what I need to compare is the previous two. Oh, I think I can use this one as well. No, you cannot use this one. Yeah, you cannot use this one. You have to compare the most adjacent two. Right, so basically I shall larger than 2 and array I minus 1 is larger than array. No, smaller than array I minus 2. Right? So that happens, then works equal to false. Right? So, other situation. If I is larger than 0. How do I describe all the situations? Okay, so this is the next situation will be you have some on the left, you have something on the right, right? So I is larger than 0 and j is smaller than array dot length minus 1. Okay, So if these two, if this situation and the array I minus 1, right, array I minus 1 is larger than array j plus 1, then works equal to false. Otherwise, I plus plus, right, I plus plus, and then j plus plus. So we'll keep moving until we hit the end. Okay, so now I want to get out, I can just say if works, right? If works, then we can try to shrink it. So we say high equal to mid. Else, if it does not work, then we need to delete more, right? So we say low equals mid plus 1. And blah, blah, blah. Once we get out, what do we do once we get out? So it works, high equal to mid, and and I say it works. If it works, high will equal to mid. It doesn't work, low equal mid plus 1. I think it's still returned low. Okay, we'll run some examples, see if it works. Not really. The first one output is 5. Oh, that's definitely not right. 5. I mean, you remove 1, 2, 3, 4, and remove 5 will work. Wait, what do you mean, like, once you get to, so if it works, so high or you go to 5, right? Because I start with dot length 1, 2, 3, 4, 5, 6, 7, 8. We start from 8, and then I go to 4. I think it's 4. It says it's fail. 4. Mid is 4. First of all, this is just mid plus 1, mid minus 1. I don't have to do I. Three, right? 0, 1, 2, 3. So I'm in here, and then oh, I shall keep going on. Yeah, because move this is false, but we can try the next one. We can try the next one. We can try the next one. So basically, as long as one of them is true, right? As long as one of them is true, shall be fine. So, yep, I think that should be like this, right? If this, basically you don't do anything because that's not what you want. I want to find a true, right? I want to find a true, which means if it's this, continue. Yeah, because it's false, right? If this, that you continue. If this, continue. If this, continue. Right? And If otherwise, continue. Well, it should be I++ and then continue, right? Or let's just put them together then. So if this, no, I don't like it. Maybe I can go I++ here. Can we do this? Otherwise, we say works equal to true, and then we'll break. Let's see if this one works. Nope. Maybe it's this. I don't know the syntax. I think that is the syntax. Okay, so we got the second one wrong. It's all right. Wait, take a look. So the second one is 5, 4, 5, 4, 3, 2, 1. Ba, 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 ba. Right? My answer is 3. Okay, that's not right. So this is 5. So the first I try is 2. Okay, so 2, I start I 0. Oh, hold a second. Maybe I can do I equal to 0 here as well. I equal to 0. Not sure. Is that allowed? Yep, it is allowed. Right, 0, and then j is 1. So yeah, we remove this, and I say j is, and then auxiliary j plus 1, and so now we continue. Now we try this. We continue. We try this. Continue because I is larger than 2, 0, 1, 0, 1. Ooh, larger than 1. My bad. There we go. It's a little bit oversight on the indices. Oh, what the hell? Okay, so we say LeetCode 1574. Binary search. We use an auxiliary array to record whether array I to the end is non-decreasing. Then we specify a subarray length, and then sliding window it to check whether removing it can make the remainder array into non-decreasing. The checks include whether whether the subarray to the right is non-decreasing. We use the auxiliary array for this. 2, whether the subarray to the left is non-decreasing. We will keep track of each pair of numbers, right, to the left. Each adjacent pair, the adjacent pair to the left, and check whether they follow the non-decreasing order. 3, whether the how do I say this? The numbers surrounding the removed subarray follow the non-decreasing order. That's about it. Ooh, the hell. Ooh, the hell. Redo. Runtime log n. Actually, it's not log n, log m. Right? Where? No, it is log n. It's a size. Okay, we'll run this one more time. Make sure we didn't introduce any new bugs. And then we'll run it. And then it will pass. No, it's not passing. Output 0. That is neither here nor there. How did you get output 0? One, two, three, 4, 5. So you go 3. So 3 is good, right? So now you go to 2. So 2 is no good. 2 is no good. 2 is no good. 2 is no good. And 2 is no good. So it should not work. Right? It's not working. So low shall equal to hold a second. This is weird. This is very weird. First 3 should be working. Right? And then high equal to 3. Oh, and then low become 1. 1 definitely not working. Okay, system.out.println works. Try the mid. Let's see. Debug this. True, and true. Oh, that is bad. A bunch of things we need to try to check, like arrays.toString. I need to make sure that the auxiliary is correct. Yeah, a bunch of things we have to make sure first. Okay, auxiliary is correct, and 3 is true. So 1 is true. No, that's false. False. ing is the same, right? Yeah, ing is the same. Oh, I come in here. All right, so this should be break because you already have some. Yeah, this should be break. This, yeah, there's still possibility because as you move to the right, you might still get it. And this is also you have a possibility because you just have something bigger on the left and something smaller on the right. But if you start removing them, maybe there will be bigger things on the right as well. So this is bad. Yeah, so this is, yeah, definitely not possible. Right. No way to recover from this. Okay, I think this one should be right. Let's redo the whole thing. Good error. Yep, this is right. Let's try it out again. Ooh, it turns into one of those trial and error ones. Damn, expected 8, and I got only 4. What? One, two, three, four, five, six, 7, 8, 9, 10. So basically, I say, hey, so 4 should be false, right? 4. Yeah, it's bad. Because we have a 3 here, so it's all bad. So unless you remove this 3, 2, 3, 4. But then as you scan through, you have a 6, 3, so that's also bad. How? Alright, again. Oh my goodness, I should not have. Yep. Let's take a look. This is bad. Should be true, 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 and false. Oh no, true, false. Yeah, it's already false. Everything should be false. Mid is 5. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 5 is the first. 1, 2, 3, 4, 5. How? This should be a false. Right, 1, 2, 3, 4, 5 as a false. This is the only true, so 1, 2, 3, 4, 5. How? How is it possible? You're killing me, man. It's okay. Out dot print line. I string dot format. Right. Remember, it's gonna be I equals percent D, J equals percent D, and say I, J. Alright, let's see. What in the world? I equal to 4 and J equal to 8. 0, 1, 2, 3, 4. How do you even get here? How do you even get here? Because I already break. Yeah, how does I get to 4 and then J get to 8? That doesn't make any sense. Because I starts with 0. J starts with 4, right? 0, 1, 2, 3, 4. J starts with 4. Then we move on. But it's still false, right? We move on to this. I0, 1, 2. I is 2. Array I minus 1 is smaller than array I minus 2. So they shall break out. The hell? I hate it. We have to do this type of debugging. I do not like this type of debugging, especially, you know, you have to type it out yourself. Definitely not a good experience, but you know, I don't have IntelliJ anymore. This is the only way we can debug. At the moment, this bunch of print. Dear Lord. Alright, let's see. Where do we get wrong? Alright, 0, 4. The first one is true. Yes. Then I continue already. Huh? Yes, yes. The first one is true, I continue. This is true, I continue. Why are you still doing this? Oh, shoot. Now I realize why. God, Lord. It's the order. What a stupid thing. It's the order. Because this one, if it's true, then this one won't be evaluated. Ah, man. Okay, so I need to evaluate this first, basically, right? Because if this is bad, then we don't have to go on. So we evaluate this first, and then if this can pass, then evaluate this, because if this is these or, right? So like if this fail, not if this is true, that means we cannot form. Now we have to continue. Yeah, basically this means this one does not get any checked, right? This one was not checked because I already continue. I move on. Move on means it's good. There is a possibility, but there's just no possibility. All right. Wow. Yeah, it was pretty bad. Okay, let's remove all the print statement. Man, that's an easy problem. It's not a difficult problem. It took so long. Not having a debugger is definitely giving me some issues, but that's it's a logic. It was logic. It's true, right? You have to check the most stringent conditions first, right? You have to check this first, otherwise it'll get skipped. It'll get skipped, and you will think that it will still work. It will still work. No, once this does not work, it does not work. This is the most stringent one, right? It's the most stringent one. Okay, so yeah, it's a good problem. And then let's take a look. 2 pointers. Do you do binary search? Oh no, not even binary search. Damn. You can do this without binary search? Oh shoot, I think you do not need binary search, because you do this auxiliary and you start from here, right? And then you say so you go all the way here, and then you start to reduce, because from this side down is all good. I don't know, how do you do 2 pointers without going through? Okay, I have a right. All right, larger 0, right? So we move on to the first. That is, if this larger equal to right minus 1. So we stop at the first, that this is smaller. Okay, so we stop here. Answer is right. Yes, because if you remove this amount, then you will be good. No, right is here. Okay, so this is the right, which is also answer, right? Okay. And then, are you saying we're just trying to shrink it? Yes, because we know I cannot allow this one to not be removed, right? So this one has to be removed. So just go left, keep going until we find the first one. So we keep going, right? And then, because I know delete all these will work. And so start from this, we check if this is smaller than this, then we don't have to delete it. So we move on here. Smaller equal to, don't have to delete it. This one, so we have to delete. Right? This one has to delete because this one's larger than, so that's it. The first one that's larger than this, right? Oh man, that's it. Actually, no. I mean, look at this. Left equal to 0, or array left minus 1 is smaller or equal to array left. So this is to make sure. Yeah, this one should be go here, right? This is the same thing. So this is to make sure that on the left hand side is all good. Then we're gonna start to say the next valid after array left. So we have array left. So we need to check and array left. If array left is larger than array right, then I need to move. Okay, I did not see this one. Then we have to move it to the right. And move to the right. Oh, you're trying to find all of them, and then we just compare to the answer. Right, so I have the current left, so I need to move array to the right. And on the left hand side, it has to be sorted, so it's the smallest, so we move to the right. Okay, once it's good, then I can get an answer, and then we move. This is brilliant. Very good, very good. This is better than mine. At least it's faster. I don't think it will actually be faster, but this is pretty good. And also it doesn't require an auxiliary array. 2 pointers. This is the 2-pointer solution from the official solution. The right index starts at the leftmost index such that array j to the n is non-decreasing. Non-decreasing. The left index I starts at 0, and for each array I, we move j to the right until the first number, the first array j, is larger or equal to array I, right? Then it is guaranteed that array I plus 1 to j is the smallest, shortest subarray given the current I and j to be removed such that the remaining is non-decreasing. We must also ensure that array all the way to I plus 1 actually is non-decreasing as well. Okay, so this is ON. Very good. So int j equal to array.length minus 1 while j larger or equal to 0 and array j minus 1 is smaller or equal to array j. Okay, j minus minus, I think it has to be larger than 0, right? As long as this minus smaller or equal to j, so j move forward, smaller equal to j move forward, so until we cannot. Okay, so int rest is equal to j. Since array j to the end are sorted, are non-decreasing, we can remove array all the way to j. Right? Okay, next. For int I equal to 0, right? I definitely smaller than array.length. And I is equal to 0, or no, I larger than, no, I equal to 0, or array I must be large equal to array I minus 1. Okay, I plus plus. So for each I, we'll say we have a j, right? We're gonna say while j is smaller than array.length, and array, because we check array j, if it's smaller than array I, j into plus plus, right? And once we done this, so res are equal to math dot minimum res, and we have I is something we want to include, right? I is something we want to include, and j is the leftmost that's larger equal to. Okay, so we will remove the things in between. So j and I we want to keep, right? So it's gonna be j minus I minus 1. No, j minus 1 plus, wait, j minus I 3 minus 1 is the length of the thing in between. Okay. Okay, so once we've done that, and then at the end, we'll just return res. Because we basically just find everything that's possible. Okay, so what if j comes to the end? If j comes to the end, we shall keep going, right? Because I keep moving. Yeah, I think this is it. Okay, let's try this one. Don't look at a solution. Oopsie doozy. I got a -1. That should be 0. How'd you get to -1? Array is here, right? Yes, j minus minus. Yes, j minus minus, and then j comes out, the rest should be 0, right? I equal to 0. I think also need, I think it should be I smaller than j, because we need to remove, they cannot be the same. I must be smaller than j. Okay, try it. I'm surprised it's actually slower. I don't know why. Should be faster. Yep, it's smaller than j. Yep, it's the same. Okay, it's done. I'll see you guys tomorrow. Adios.